Let us start with the IUPAC nomenclature of coordination compounds. So the first thing you should always keep in mind that the cation is named first. Cation is named first and then the anion. So I'll be telling you in points the rules or the ways how to name the coordination compound. The first thing that cation should be named first and then anion. Now in naming coordination sphere, ligands are named in ligands are named first. I am talking about the coordination sphere, which is inside the square bracket. So in naming coordination sphere, ligands are named first in alphabetical order. Okay, followed by metal atom, and then after this metal atom, we are supposed to write the oxidation state of the metal. Right? This should be oxidation state of the metal. It should be represented by Roman numeral. So this should be written in Roman numeral rather, in parenthesis, means in bracket. Now the next thing, no doubt, we'll be discussing by taking examples. So it will be more clear when we take actually the examples. Name of anionic ligands end in O from IDE. Means for example, like ligand is suppose chloride, which ends with IDE, so it should end with O, that is chloride. This chloride is written, or that is end with O, that is chloride. Like sulfate, sulfate of O, and so on. Now the next will be the name of the complex. It's one single word. The name of the complex should be a single word. That is name of the complex. There should be no space in between. No space in between different ligand as well as ligand name and name of the metal. So the name of the complex should be written without giving any space in between. This is important. Then I can write here no space in between. Okay, but you can put the space if this chloride or sulfate, these groups or these anions are present outside the coordination sphere. You can give the space, or if the atoms or the metal atom which is outside the coordination sphere, you can name them first and then you can write the name of the complex. Means ultimately what does it mean actually? The thing which is inside the coordination sphere, there should be no space. While naming the part which is inside the coordination sphere, there should be no space. Whatever is the thing outside the coordination sphere, you can put the space. So we will see examples based on this also. Next term, name of cationic ligands. End in name of the cationic ligands end in IUPAC. Okay. For example, NO2 plus. So for this you can write nitronine. This is nitro group actually. So you can write here nitronine. Okay. Next we'll go further. Now the certain ligands those are represented by abbreviations in parentheses instead of their complex structural formula. The ligands like ethylene diamine, like ethylene diamine, ethylene diamine. So instead of this whole thing, you can write EN in parentheses. Next, ambidentate ligand are named. Ambidentate ligand means where they have two donor atoms. So ambidentate ligands are named ambidentate ligands are named by using different names of ligands or by placing the symbol of donor atom. For example, for this ambidentate ligand, I will explain this by taking example like HCl. So you can write for this thiocyanate. This can be written as thiocyanate S or simply thiocyanate. If it is written like this is ambidentate because there are two donor atoms, sulfur and nitrogen. Here sulfur and nitrogen. These are the two donor atoms of metals and such ligands are called as ambidentate. So for this you can write thiocyanate. It means that there is a bonding between this nitrogen atom and the metal atom. This nitrogen here is the donor atom. Or this is also written as isothiocyanate. Isothiocyanate when it is bonded to nitrogen. Remember, this is actually N. Like one more example, you can write ON2. This is written as nitrito O, or simply nitrito. So when you write simply nitrito, it means that the bonding is through oxygen. And same thing if you write this way, NO2, you can write again nitrito N, or you can write nitro. So this is about the ambidentate. Now sometimes what happens, a single molecule of the ligand contains the word like di and tri. Di and tri, it is actually present in its name. For example, like ethylene diamine. So this di word is there. Or another example, we can write like trialkyl phosphate. Trialkyl phosphate. Trialkyl phosphate. So here also there is a tri word is there. In case of this, there is a di word. So to avoid confusion, when there is a di or tri, if there are two molecules of this ethylene diamine or two molecules of trialkyl phosphine is bonded to metal atom. So di, you can't write this way, trialkyl phosphine. No. So instead of this, the word like bis, tris, and tetrakis. Such words are used here. Just these are the prefixes in Greek language. These are the prefixes in Greek language. So where this is applicable, these words base, trace, tetraphase, these are used where in case of such ligand where there in the name itself there is a word like di and tri or tetra is present. Okay. So this is just to avoid the confusion. The word bis, if there are two trialkyl phosphine molecules are attached to any metal atom, so you can write bis trialkyl phosphine. If there are two ethyl diamine molecules are bonded to metal atom, you can write bis ethylene diamine and so on. So for example, I'll try to explain this here itself for this particular this point. If the complex is like this is ethylene diamine, Ca2Ca. So while naming this, how do you name this? This will be first we'll have to go alphabetically. So here there are C. Here you can write dichloro. First comes C. So start with there are two chlorine. So you can write here dichloro. Then there are two ethylene diamine. So write down this in bracket. You write down ethylene diamine. Diamine. Then there should be no space in between, as I told. So this is the thing inside the bracket. So no space in between. This cobalt is also in the inside the square bracket. So while writing, starting from this end to this end here. Inside the coordination sphere, there should be no space in between writing the name of each and everything which is involved in the coordination sphere. So dichloro, this ethylene diamine. Okay, so this base is for this two. There are two ethylene diamine molecules. Then right next to very next to this, write cobalt, that is the metal. Write here the oxidation state of the metal, and then this chlorine, or rather the chloride, it is outside the coordination sphere. You can give a space here and then write chloride. Okay. So here I wrote on the cobalt. In some of the cases, you might find that it is written as cobaltate. So where do we write cobalt and where do we have to write cobaltate? This is also an important point to be discussed. That is the metal ion. I'm talking about metal ion is named with ATE, ending with ATE in anionic complex. In anionic. Okay, so for naming also, we should be able to understand whether it is a cationic complex or anionic complex, what is the oxidation state of metal ion which is involved in the complex and so on. So the metal ion which is involved in the anionic complex in that metal ion should be written as ending with AT, like cobaltate, aluminate, iron, and so on. Now, the first thing we go by example that will be more clear for you. This is the complex like this. H2O thrice inside the outside the coordination sphere there are three chlorine atoms. So first we'll go for this. Whatever is given inside this coordination sphere, we'll name them first, and that should be again alphabetically. So this is ammonia molecule here. So this ammonia, which is a neutral ligand. So there are three ammonia molecules are there. Here you can see there are three ammonia. So right here, triamine. So while writing this amine, there should be double M. Remember, triamine. There are three water molecules. So right here, triaqua. This water molecule, according to IUPAC, it should be named aqua. and then comes, so we are finished with this, we are done with this also, so we are left with the metal. So here you write down chromium, no space in the chromium. Now the important thing, what is the oxidation state of the metal atom? So for this purpose, you should be aware what is the type of the ligand which is involved. Now since this ammonia molecule, it is a neutral ligand. Water molecule again is a neutral ligand. That is, there is no charges on them. Okay. And there are three chlorine atoms outside the coordination sphere. So charge on each chlorine and rather chloride ion, that is -1. There are three chloride ions outside the coordination sphere to balance the primary balance. This is the primary balance. And the metal atom which is attached to this ligand, this is the secondary valence. So this to satisfy the primary valence, what is the charge on this 3 chloride? That is -3. Okay. And this ammonia, it is a neutral one, so no charge. Water molecule again a neutral one. So here the oxidation number is 0 in both the cases. So to balance this -3, this should be +3. But the total charge always be equal to 0. So if this is coming to be -3, so this must be +3. So easily you can write here. Okay, this is the oxidation state of chromium, and then write chloride. This chloride we are writing for this. So there is no need to write trichloride and so on. This is not at all required because this oxidation state of this metal ion, it itself gives you an idea that there should be 3 chloride ion attached to this metal to balance the charges on them. So you should have some prior knowledge about the oxidation state, what is the type of the ligand, which ligands are neutral one, which are anionic, which are having the charges on them. And it's very simple. Now the next example you can take. Now I'll write the name tricarbonato cobaltate. Tricarbonato cobaltate 3. Now you can see here this is cobaltate here it is. So this is the hint for you is that it must be an anionic complex because metal ion is named with At in anionic complex. So first go from this in tricarbonate. And what is the metal ion here? Cobalt. So you can start writing. This is cobalt. How many carbonate are there? 3. So CO3 and 3. Now the question remains, as I told you that this is cobaltate, here it is given cobaltate, so it must be an anionic complex. So here there must be negative charge on this. So what should be the charge here? So for this, you have to look for this ligand. This is carbonate. You know that carbonate it carries -2 charge. Since there are 3 carbonate are attached to this cobalt, so the total charge here it would be 3 into -2, and that would be -6. Okay. Now, here in the name which is given to you, the oxidation state of cobalt is given, which is +3. Okay. This is given. So this is +3. So how do we come to know this is +3? From this name itself. So some of the information you can get from the name itself. So it becomes easier for you. So this +3, this is -6. So what is the remaining charge on this? That is -6. So we are not expected to write the charges here. Remember, this is for your understanding only. I left it here. So the name of this complex will be CO3 thrice and 3 times. Okay. So from the name which is given, you should be able to write the correct formula for this complex. Now the next example will take sodium hexacyanoferrate. Okay, sodium hexacyanoferrate. Now, if when this sodium, which is again a metal, and this ferrate means Fe, this is also a metal ion. Now remember, this sodium, this is outside the coordination sphere. You should never make the mistake that this is not included in the coordination sphere. So here there is a space. There is a space here. I'm writing. So this is the part, or this is the entity which should be in the coordination sphere. This much. Okay. So whenever this sodium, it is written first, isn't it? As I told you earlier also, go back to the first slide, the first one. Cation is named first and then the anion. So this, if this cation is outside the coordination sphere, then it should be named first and then anion. Okay. And when you name the coordination sphere, ligands are named in the alphabetical order as usual. So when cation is named first, it means that this cation is not in the coordination sphere. Remember. So first we go for this hexacyanoferrate. So now ferrate means Fe. How many cyanide are there? Hexas. 6. Isn't it? Now there is nothing in the coordination sphere. So you close the bracket here. Now as you know, all know this cyanide here. There are each cyanide it carries -1 charge. So there are 6 here. So here it is -6. Here it is given 3. And this should be +3. Okay. So the resulting charge on this complex here, this should be -3. Now how many sodium? Now remember, this sodium, as I told, this is outside the coordination sphere. I am talking about this. So this is -3. So how many sodium should be there to balance this -3 charge? Because this -3 here, it is an anionic complex. That is why it ends with At, that is ferrate. This is again a one more here. So to balance this minus charge in this complex, here there should be +3. So each sodium ion, it carries +1 charge. So there must be 3 sodium atoms here attached to balance the primary valence of this coordination. So this is the way you go one by one. Okay. Now the next example. Now I'll write the next thing. Now I'll give you the formula and then we'll try to name this. Here, charge on this is plus. This is cationic complex. Now, first, what we will do? We just have to go for this. There is nothing outside this coordination sphere. So first, we'll, in such case, we'll go first naming the ligand alphabetically. You can put the bracket here. So here, first water, that is aqua, isn't it? A comes first, and then chlorine is also there, and ethylene. This alphabetically, first we'll have to go for this water molecule, then this chlorine, and then ethylene. So we'll write aqua. Here there is only one water molecule, so only write aqua. Then only one chlorine is there, so chloro. Now there are two ethylene diamide. So we have to write here this ethylene diamide. So this should be continuously, no space should be there. Ethylene diamide. Now comes the metal. Again, there is no space. Cobalt. Now the important thing, what must be the oxidation state or oxidation number for this cobalt? Now it says there are +2 charges here. Now it go by one line. Now this ethylene diamide, it is a neutral ligand. Water molecule again a neutral one. This is the only ligand which carries a charge, and charge on it is the minus. So this +2 -1. So here this is -1 and resulting charge is +2. This is the resulting charge. This thing. This is if this is -1 and remaining we want here +2. Now if I write here +3, isn't it? So +3 -1, the resulting would be +2. So here you can write 3. So the oxidation state or oxidation number of cobalt in this complex, it is 3. Though it is not given, but you have this hint in front of you. This resulting charge, it should be +2. So to get this +2, we have this thing in front of you. We have no pre-knowledge that these are what are the types of ligand, whether it is a anionic ligand or neutral ligand and so on. So we should have some pre-knowledge while naming. This is it. Now cobalt 3 iron. Even if you don't add iron, it's fine. Now the next thing, again we'll try with, we'll give you an example like this. We'll give you the formula and we'll try to write the name for this. This is inside the coordination sphere, one chlorine atom outside the coordination sphere. We'll have to follow the same thing as we did for this. So first go for this, whatever is inside this coordination sphere. Now remember, this chlorine, it is, don't write this in the beginning. Remember, this should be written at the end. So start writing for this. How many water molecules are there? 4. Alphabetically, this is aqua and this is chlor. So tetra aqua, not aqua, this is aqua. Aqua. There are 2 chlorine, so dichloro, chromium. Now here comes the again question. What should be the what should be the oxidation state of chromium? Now remember, there is one chlorine atom outside the coordination sphere. There are 2 chlorine inside the coordination sphere. So this chlorine atom is for balancing the primary valence or satisfying the primary valence for this chromium. Okay. These 2 chloride anions or ligands, these are for the secondary valence. And we know that water molecule, it is a neutral. So this is Cl2, means total charge for this 2 chloride will be -2. Now there is only one chloride outside, chlorine atom outside the coordination sphere. So if you say that it carries -1, so this is -2 here. Okay, now we'll have to go for this. Now here CrH2O4 Cl2. Now for this one, tetra aqua dichlorochromium. Now for this one, there is only one chlorine outside this. And if I write this as a chromium as a +3, so +3 -2 is the resulting charge for this will be plus 1, isn't it? So to this balance this plus 1 charge here, we need here minus 1. So plus 1 minus 1, it would be 0. So if I say this chromium is having the plus 3 oxidation state, that is the correct one. So you can write here. I repeat for you. There are two chloride ligands here, isn't it? So each chloride carries minus 1. Since there are two, so this should be minus 2. We are having this chlorine atom outside the coordination sphere with minus 1. Okay. So first thing for the charges inside the coordination sphere. Okay. Now, if this is minus 2, we are not aware what is the oxidation state of chromium. So, but we know that there is a one chlorine outside the coordination sphere with minus 1 charge. Now, means here the total charge, whatever is inside this coordination sphere, it should be plus 1. So to bring this plus 1, this should be plus 3 because plus 3 minus 2. The result would be plus 1. So to balance this plus 1, there should be minus 1. The total charge on the complex should be 0 here. What my point? So in this way that chromium is having the oxidation state as 3. And now we are left with this chlorine. So right here. If you put the space in between writing whatever is outside the coordination sphere, it's this way. Now I'll give you the name of the complex like this. Right? Dichloro dichlorido dichlorido bis ethylene diamine cobalt 4. Okay. So here how we will write the formula for this. Now dichlorido bis means that cobalt here metal, first write metal, then dichlorido means Cl2 bis ethylene diamine means ethylene diamine, two molecules are there, and here it is written this is plus 3. Okay, so this is plus 3. Ethylene diamide, it is a neutral ligand. Here there are two chlorine, so this must be minus 2. So plus 3 minus 2, so this must carry plus 1 charge. Okay, so in this way you can write the correct way of writing this is like this. Name of the anionic ligands and O from ID to ATO to AT. So this is the way you can be able to write.